Welcome to this event, to this webinar. As you can see from this first slide, the title for today is Generating Enterprise Knowledge Graphs from Taxonomy and AI. First of all, I'd like to set up the agenda for the attendees to be able for the attendees to follow more smoothly. First of all, we will introduce the topic. So generating enterprise knowledge graphs from taxonomy and AI. And then we'll first delve into why enterprises uses taxonomies. So we will also define what a taxonomy is. We'll then do the same for knowledge graphs, as those are different terms that need some clarification. Then we'll move on to the topic of classification and information extraction. What is the entanglement between these two topics, and what is the role played by the knowledge graphs? Then the most interesting, at least for me, topic for today will be the following one, which is how AI can build knowledge graphs and enrich taxonomies. Those will probably be the topics that also the attendees are most interested about. Then, of course, we will have, we would like to give you some takeaways to carry back home, and we will have some space and time for a live audience Q&A. As you may have already grasped by this first introduction, I'll be the host for today. My name is Simone Abbiati, and I'm the Head of Training and Education at Squirro. Today, I have the pleasure to have here with me two guests. One is Dave Clark, Chief Innovation Officer at Squirro. Hello, Dave.
Hello.
And a second guest, Daniel Loop, Civil Engineer at Arup.
Hello.
Hello, Daniel, and thank you again for being here today. Before delving in the topics that we introduced in the agenda, I'd like also to introduce what and who Squirro is, for those among us who don't know the company yet. Squirro is a software company specializing in enterprise search and in using generative AI for search, insights, and automation. We have served already quite a few prominent financial institutions and many other institutions, from R&D use cases and many others. As you can see, we work with Bank of England, Standard Chartered, Henkel, also with the European Central Bank. We have received a few important recognition steps and awards. Probably the most important ones, last year from Gartner, we were considered and declared as one of the representative vendors for conversational AI, and this year we have been inserted in two different magic quadrants, one for Gen AI engineering and the second one for knowledge management. We have quite a few investors backing up us. We have the headquarters in Zurich, but we also have a strong presence all over the world. Today, we will be discussing knowledge graph. Why is this important? As I introduced, the company, Squirro, specializes in enterprise search. So basically, we gather the relevant information for a singular enterprise, we curate, we enrich the data set, and then we give to the end user the possibility to chat with the relevant information. We give to the customer a chatbot. Why, though, we needed also another company, Synaptica, a company that we acquired last year and who specializes in taxonomy, ontology, and knowledge graphs. We needed another nuance there, because as many of us know, one of the most important problems with LLMs is the topic of hallucinations. When we insert our data into a RAG pipeline, of course, we are augmenting the data set and the accuracy and the relevancy of the data that the chatbot can retrieve. But we need to discuss also the possibility to pass from a framework of, let's say, probabilistic AI to a second one, to a more deterministic AI. And for this topic, I'd like to leave the floor to Dave, who will present us a little bit more in depth what Synaptica specializes in and why this acquisition and this team between Squirro and Synaptica make sense. But before leaving the floor to Dave, I'd also like to hear from an employee of Arup how to introduce this company. So, Daniel, the floor is yours.
Sure. Thank you, Simone. Arup, as a firm, it's my pleasure today to join this event, I should say, and be invited to share Arup's taxonomy and ontology management journey, as it were. So Arup, as a firm, is dedicated to sustainable development and is a collective of designers, consultants, and experts. Founded to be humane and excellent, we collaborate with our clients and partners using imagination, technology, and rigor to shape a better world. We guide, plan, and design the future of the built environment, and increasingly so the natural environment. We are a global consultancy with advisory and technical expertise across more than 150 disciplines worldwide. Next slide, please.
Yep. Thank you, Daniel.
Thank you. So Arup was founded by Sir Ovi Arup in 1946 and currently has over 19,000 people worldwide, working from 94 offices spread across 34 countries. And so, as you can imagine, there are a variety of taxonomies and ontologies and knowledge that needs to be shared. So, thanks.
Okay, thank you, Daniel, for this introduction. For sure, we will hear a little bit more and we'll discuss together a few use cases. So, first topic, as we pointed out in the agenda, will be enterprise taxonomies. So for this question, as I was saying before, I'd like to ask Dave to help us clearing some of the foam here. So I have a few questions for you, Dave. You can tackle them all together or one by one, you'll decide. So first of all, we would like you to understand what an enterprise taxonomy is and how it is used. Maybe you can give us some examples of typical use cases. And related to that, we would like to ask you what is then the value proposition for taxonomies. Dave?
Thank you, Simone. If I may, I'm gonna flip that on its head, and I'm going to value proposition first. There's a traditional value proposition for taxonomy, and it's essentially that it aids information retrieval. And this is a field that my company Synaptica, now part of Squirro, has been doing for many years. I've been in the industry for a long time. But the problem hasn't really changed. The value proposition hasn't really changed. We help people to organize, classify, and discover knowledge. And that can be public-facing information on websites. It can be behind the firewall enterprise data. Everybody is managing very large amounts of data. And so there's a phenomenon in information science called the precision recall trade-off. And what that means is if you just do text search, whatever you do to improve the amount of information that comes back, the recall, will diminish the precision. You'll get noisy, you'll get noise results in there that you have to wade through. And conversely, whatever you do to improve the precision will diminish the recall, which means that there are some things you should have seen that you don't get to see because you put too much criteria, if you like, in the text search. Now, one of the best ways to, or the industry proven way of getting the best recall and the best precision is to do taxonomy. And that is really creating a bridge of language between what your users talk and the language that is in documentation. So as a fundamental value proposition, this offers some benefits which are on the far right. You can use a taxonomy, or very often businesses have many taxonomies, and certainly Arup does. You can use taxonomies to create a unified way of getting at content that lives in lots of different places. You might have it in SharePoint, you might have it in Adobe Experience Manager, you might have it in all just the plethora of content management systems and databases that businesses use is large and varied. And a taxonomy is a way to unsilo that content and bring it all together. It can improve both precision and recall, which reduces time wasted on irrelevant results, and it means that you're not, or you reduce the risk of missing key information. And if you're in a highly regulated area of compliance, missing information is far worse than wading through irrelevant information. Because taxonomies are structured, they can also help findability. They can be built into information architecture. They can drive website navigation and many other content recommendations and so on. So many benefits of many benefits of doing basic taxonomy. If you could do the next slide, please. So now there are more additional value propositions from doing taxonomy. And if you are a company that already has taxonomies and ontologies, one of the key messages I want you to take away is you can leverage what you designed for information retrieval to feed it into business process automation. And we'll talk a little bit about this later on in this session. So a way I have of describing taxonomy ontology is we are transforming human readable knowledge into machine readable knowledge. We're now all engaged in the next wave of AI, which is goes under agentic. It's like how you build assistants and agents to help automate processes, and machine readable knowledge is a key enabler of that. So it's really, we're living in a very exciting time. Next slide, please. So who is doing this? Essentially, we work with just about any type of company you can imagine, from cancer research through to publishing, through to food delivery, fashion, media. Everybody has large amounts of information. Everybody needs to improve the precision and the recall and to get to siloed content and to improve discoverability. So there's a role for taxonomy ontology in just about every industry that you can imagine. The persona that we have, the roles, if you like, that we've worked with over the years has definitely changed. So we used to work only with people called taxonomists and then ontologists. But now the interaction between taxonomy and content classification and content enrichment is very broad. So our users tend to be taxonomists, traditional base, but content managers, metadata managers, information architects, and data scientists, more and more data scientists. So this is kind of like the picture of who's working with this. Next slide, please. And use cases. Information retrieval, that was the main one I mentioned. Other applications for taxonomy and ontology that we are working with, CRM, customer relationship management, human resources, engineering design, product information management, supply chain, business process management. These are, to list is to limit. There are others, but that is sufficient for one slide. I'm now going to hand over back to Simone. Excuse me. Back to you, Simone.
Yeah. So the next question, the next few questions are for Daniel. So Daniel, you introduced to us Arup, your company, and you define it as a multidisciplinary consultancy firm. So we would like to ask first, how your company and why do your company uses taxonomies? And second, we heard from Dave that many different personas interact with taxonomies in different ways. So we would also like you to explain a little bit what type of profiles, of job profiles, interact with those resources. Taxonomies, content manager, data scientists. So these two questions, how and why do you use taxonomies and who uses them? Daniel, to you.
Sure. So on the first point, really along Arup's kind of digital transformation journey, it was clear that as we were often either using certain tools and softwares, but also developing and building our own tools and digital workflows to deliver value to our clients, that within that we would have a variety of taxonomies, and in a sense dependent on the exchange of data from, say, one tool to the next along a project workflow. And so our target state was to kind of form have a sort of global, what we term a global taxonomy register, which is hosted on Graphite. And with this, it addresses the fact that the data quality management, including the cleansing, transforming, and exchanging of the data, is a very timely and costly process. And by also interacting with evolving taxonomies, both internally and, say, externally with our clients and collaborators, say, to produce standard deliverables in a particular file format, or either as a 3D model or a set of data tables in an Excel file, that it would enhance the consistency and interoperability of that, and reliability of those digital workflows over time. And so those workflows can consume the structured knowledge that's stored within Graphite and generate project data to unlock new value through automation. One example being our global Revit standards, where Revit is one of the core building and information modeling software that we use, with over 5,000 staff using it globally for over 2 million hours per year, approximately. So until recently, the Revit standards had been managed independently, region to region, which made sharing the resources and automation routines and data between projects very difficult. And so also the data structures that were present in the Revit standards were locked in this proprietary files, which made it us unable to reproduce them for use in other software. And so we were able to convert those standards, which were previously managed in a series of Excel files, into an RDF format that we could import to Graphite. And so this enables automated parameter injection and consistent naming across our BIM content, and reduces the duplication. And in terms of the second point, it's quite a mix in terms of the typical job roles of the key stakeholders in our taxonomy and ontology management. We have a center of excellence, which is mainly consists of data scientists and data engineers that kind of develop best practice guidance on taxonomy and ontology management, and we then support our domain experts that contribute to domain-specific taxonomies, say for specific disciplines like bridge engineering or water, or building envelopes, as is shown on screen there, taking our existing building envelopes taxonomy and enriching that and expanding that by mining for other concepts. And so, yeah, it's increasingly a mixture of skills and experiences that are getting involved.
Okay, thank you, Daniel, for this. Of course, like as we may know, like data, the structuring of data is one of the most important topics at the moment, given the willingness for enterprises to adopt AI. Without structured knowledge and without a curated starting point, it's really difficult then to augment that type of tools. That being said, we arrived at the second topic, the following topic, which is this time knowledge graphs. We introduced taxonomies, and we discussed a bit how they can be used. Knowledge graph is another topic that again should require another set of questions. So this time, back to you, Dave. This time, I'd like to ask you first the value proposition, since you prefer to start with that last time. So I'd ask you to explain to us that, and then as a follow-up, to describe some of the typical use cases, and what kind of verticals of enterprises need knowledge graphs. So again, Dave, back to you.
Thank you. Thank you, Simone. And just commenting back on what Daniel said, a couple of things that I heard there, Daniel, which are interesting, is you were talking about unsiloing as one of those value propositions, how you've got data in lots of different places, and by bringing it into one place, you could kind of see the whole picture. And that was really music to my ears, because that's what we hope to help people to do. Right, knowledge graphs. Next slide, please, Simone. So I'll go through these fairly rapidly, because this is pretty fundamental stuff, but we've got more specific things to get to. Data, we all kind of know what data looks like. It's very granular, bits of information. It could be a single value in a table, but and it comes in different formats, textual tables, media feeds, and so forth. Information is a little bit different. So I'm offering to you a definition of information here, which is it's data that has been compiled or formatted or assembled in a way that humans can consume it and understand it. It becomes informative. Data becomes informative when it's assembled in a way that we can understand it. And that's often documents or reports. It could be structured queries that get data out and then arrange it into, on the fly into a meaningful format. That's information. Now we come to knowledge. So knowledge is fundamentally different than both data and information. Knowledge is not documents. Knowledge is not data tables. Knowledge is connections between things. Knowledge is how we as human beings interpret and interact with information and data. And so when we talk about building knowledge graphs, we're talking about building a meta level above information and data, a level that connects things. Next slide, please. You could draw this stack in lots of different ways. This is a way that I can talk to it in this context. So kind of think of data and information at the bottom of this stack. Then there is a semantic layer. Semantic layers become a phrase that's quite popular these days, but essentially in that semantic layer, we're adding on top of the pure information and data, we're adding ontology, taxonomy, knowledge graph representations. We can even represent business process flows and decisions in that format. Above that, if you are already into AI and AI agents, you might have an agentic layer. You might be doing RAG. You might be doing business process automation. You might have LLMs. And then above that is the things that help get this information out and assembled into meaningful ways. So insights, business insights layer, perhaps conversational search that's talking to the RAG and so forth. Next slide, please. Next slide, please. Thank you. Oh, sorry, back one. That's the one. Thank you very much, Simone. I said machine readable knowledge, and this is a view of a knowledge graph. So I definitely see a knowledge graph as comprising three tiers. And at the very, very top, we have the schema of the knowledge graph. And think of that like the entity relationship diagram in a relational database. In a knowledge graph or a graph database, you have schema. And we do things in RDF, which means that that schema is predicates, classes, and so forth. They define the logical structure of the knowledge graph. Beneath that, you have named things that will conform to that schema. And we typically call those taxonomy, but a taxonomy could be, if you're technically so disposed, it could be OWL classes, it could be SCOS concepts, it could be other kind of entity types, but they're the named things that conform to the schema. And when you have those two things together, you have an ontology. But the knowledge graph doesn't stop there. At the bottom of this pyramid, and by far the biggest thing, is going to be a graph of data, a graph of content, a graph of instances. And if we do, for instance, classification of data, of content, then what gets written to the bottom of the graph are all the connections between bits of content and concepts and between concepts and so forth. So that is kind of the bottom of the graph. The top of the graph for us has to live in RDF. RDF is a reasoning language for data model. The bottom of the graph could be a label property graph, or it could be still in RDF, but that's kind of the machine readable representation. Right, let's move on to, yeah, so back to you, Simone.
Okay, so as before, I'd like to ask Daniel this time about his team and about how you, Daniel, use knowledge graph in your enterprise and with your team. How do you engage with these tools?
Right. So one example has been where we're engaged with the Environment Agency in terms of our water business, and so under their framework, they have a set of standard deliverables that all suppliers, i.e., consultants and contractors, are to produce at the end of each project delivery stage across the whole project life cycle, so which they define as a kind of 7 stage process, and so with that, they also have their own data requirements library, which is in itself an ontology of the types of assets that the Environment Agency manages. For example, flood defense assets, like embankments or walls, or and so that breaks the asset down from its category defense to the asset embankment and its elements, and for each of the asset and its elements, those have a set of attributes that are required at kind of cumulatively across the delivery stages, both in say their geospatial construction operations, building information exchange, GeoCOBE file format, which is an Excel-based set of data tables, but then also they have, say, their whole life carbon assessment deliverables, where they have various parameters that say to calculate the embodied carbon of an element, say based on the material type and the volume of that element, and so by having the EA's ontology in Graphite, we could then also map relationships between our ontology of the asset, both in different softwares, say when we design the asset in a 3D model and pass that data to a project database, which also would have its own ontology, say, to store data for every instance of an asset within a given project. And from there, then we could push the data to GeoCobe file format, for example. And then that also enables us to explore adding additional kind of semantic relationships, say, between those concepts. For example, taking the United Nations Sustainable Development Goals, we've been exploring, say, mapping the relationships for a given asset. You could say that asset contributes to a specific goal, indicator, target, a specific series, which is essentially a parameter that could be calculated through design or through assessing the condition of an existing asset. So we are then able to kind of have data-driven workflows across different stages of an asset's life cycle and enrich that.
Okay. Thank you, Daniel. So again, with once data is classified, we can then derive information, and from information, knowledge. You gave us some very specific examples, hands-on examples, and from them, of course, other verticals can think of mirroring those processes. But again, once data is classified, it could be transformed into information and knowledge. So from here, I'd like to pass to the next topic, which is classification itself and information extraction, which is quite a big topic. So I'd like to, again, leave the floor to Dave and ask you to unpack this intersection between classification and information extraction for us. And then once you have explained and introduced the topic, I'd like you again to give us some use cases of this of these processes. Dave.
Thank you. Okay, so classification and information extraction embodies a few things, and it goes by lots of different names: text analytics, auto classification, auto categorization, information extraction. Effectively, what we're doing here is we are often starting with a taxonomy, but not necessarily starting with a taxonomy. We're looking at content, and that could be unstructured documents, semi-structured data. And we're doing a couple of things. Tagging, and there may be other names that people use for this, but tagging is what we would call identifying the many things that are mentioned inside a piece of content. And we distinguish that from classification, which identifies the few. So tagging is like, I've got 50 things that were talked about in this fairly lengthy technical document, but what is the overall document about? What is the aboutness of that document? Then we go into classification. Classification can be processed derivatively after tagging. So you can look at all the specific things, you can aggregate, you can take them back to the graph, and the graph will start building connections between them that help determine the classification. In other words, it isn't that one topic, one phrase was mentioned 20 times and another was mentioned twice. That's not the only way you get to the overall aboutness. You actually look at the overall graph and intersections between things. So that's classification. Then we have entity extraction. This identifies the new. So we've got identifying the many, the few, and the new. With entity extraction, we are looking for things inside content that are not yet in the taxonomy, but perhaps should be. And that used to be the realm of NLP, and today it is the realm well, it's still the realm of NLP, but we've been working on doing that with LLMs, and the results are significantly better when we bring in large language models for that kind of extraction. And lastly, under this general umbrella is fact extraction. And fact extraction might be, for this entity, for this thing, find me the value of a certain property. So that might be a numeric value. It might be a language value. And also, we identify the linkages between things, the relationships between things, put those all together, and it's fact extraction. And we can do amazing things. We could process company reports and identify the shareholding structure and the share ownership percentage between entities. We can use this for engineering. We can use this in lots of different domains. Next slide, please. So this diagram illustrates kind of a simplified but big picture of what we do with classification and extraction. So we can bring in taxonomies, we can bring in enterprise documents, corpora, we can bring in LLMs, and then in the center of this diagram, we have classification and information extraction as a process. This can do, oh, and we can bring in prompts from, if we're using LLMs as a prompt library. We then, on the right-hand flow, can build the enterprise knowledge graph. And what we're doing here is we're taking a graph of concepts, which is the ontology taxonomy, and the more content that we expose to it, the more the graph grows, because it will start finding connections between well, it will find mentions of things in sentences which link to whole documents, or maybe to a structure in the document. And then those things, those content become by inference related to other pieces of content, and all of that can go into the graph. So that's kind of growing a knowledge graph by exposing an ontology to content through a classification and IE system. If we follow the center and up and down flow here, this is taxonomy enrichment, and we can use the same or similar processes here to do things like, I've got a taxonomy, but let's start building it out. Let's create new concepts. Let's flesh out a particular branch. Let's use generative AI to synthesize definitions or to harvest synonyms, etc. All of these enrichments are actually the result of classification and information extraction. Let's go to the next slide, please. And some of the use cases, the classification feeds that basic information retrieval, which is discoverability, search accuracy, etc. We can build these knowledge graphs about content, and those can serve business insights and analytics over content. And we can actually build structured databases out of unstructured data. And when we do that, the knowledge graph isn't just a signpost to get to documents. The knowledge graph becomes a knowledge base. It becomes a source of information in and of itself. And that's very much something that Arup is doing. They've got primary information being generated and stored inside that graph. Back to you, Simone.
So you just mentioned how Arup interacts with this classification process. So again, back to Daniel, I would like to ask you more precisely, more in depth, what type of classification, how do you use classification to access the engineering knowledge and the assets that you handle on a daily basis? Daniel.
Sure. So as Dave mentioned, we've been working with Squirrel and Dave's team, say at particularly our building envelopes skills network, their taxonomy for building envelopes, which at high level consists of, say, the systems and components and materials and finishes, parameters, properties. that are interrelated, and say through the extraction of concepts from unstructured data sets, such as, say, technical specification documents or typical detail drawings or other unstructured information, we can then kind of pull out, either by feeding the LLM an existing ontology, then prompt the model to find new terms and definitions from that content, so from that kind of corpus of documents, and then propose that to the user, say to our domain experts, our facade designers and engineers, to review and approve those proposed, say, new components or products within the overall building envelopes ontology. So say an example of a concept maybe that exists, maybe laminated glass component that has then its own kind of subcomponents, say interlayer, ply, that may then have its own material, and that material might say annealed glass, and that may have its own finish, and so that then enables us to also, as we're kind of extract and classify new terminology as technology advances and design innovations evolve as well, we can then enrich our existing taxonomy with those concepts that then can be kind of easily reused for the next project or the other current project that's in another region or another location. And so then that then supports sharing that knowledge more efficiently, and so that's our main example to date, and the value that can bring.
Thank you, Daniel. So of course, at least for me, that's extremely interesting, especially because, again, we talked about data classification as the foundation for everything else. So those processes could take a lot. So if we can have an LLM suggesting as a classification and leave there an SME or an expert, a domain expert, to validate what the LLM provide us as an hypothesis, we also use those so-called human-in-the-loop frameworks, which also help us keep up with all the regulatory aspects of those processes. But of course, the possibility that AI gives us, generative AI, with LLMs, are really a big promise. Talking about that, I would like to go to the next topic, which is precisely that: how to use AI to build knowledge graphs and enrich taxonomies. You already introduced this topic, and you touched a few points already. But I'd like to ask Dave to delve a little bit more deeper into this intersection between AI, generative AI, LLMs. You already introduced in one of the last slides these topics, but I'd like you to go deeper, as this is probably the most interesting topic for today's webinar.
Thank you very much, Simone. And noting the time, I'm going to go at a fairly fast pace to lay the foundation. But everything we've done has actually been a layer cake. So we started with, taxonomy and ontology. We built on top of that knowledge graph. We built on top of that classification, which helps expand the knowledge graph and build it in many ways. And now we're talking about the AI. So I've got this slide. Sorry, it's one of my favorites. So if you've been to some of the conferences that I've spoken at recently, you may have seen this slide before, but I just love it. So when I talk about AI and how we use it for knowledge, one of the things to note, particularly with generative AI, is that the definition of insanity is doing the same thing over and over again, expecting a different result. It's attributed to Albert Einstein, but that's a pre-ChatGPT hallucination. He never said it. If you can go to the next slide, please, Simone. The corollary of that, back one, the corollary of that is, wouldn't it be insane to build machines that generate a different answer over and over again in response to the same question? And that's exactly what we did when we built generative AI. Now, the way to tame that those hallucinations is actually to pair it with structured knowledge. Next slide, please. So when probably the right answer is not good enough, this is where structured knowledge, taxonomies and ontologies come in, because generative AI on its own is probabilistic. To be extremely unfair to it, it's a glorified predictive text method. Taxonomy and ontology is deterministic. You have direct transparency of the structure and representation of knowledge, and if you're doing agentic work, of the process flows. So this makes a really winning combination to bring together these two things. Next slide and skip it. Next slide. So we built tools that are no-code. We built a no-code Gen AI platform which lets you connect to any data source. Well, not any data source, but we've got about 100 ready-made data sources, from Google Drives to Adobe Cloud to SharePoint to Salesforce to you name it. And when we have clients who are on board and they've got some other data source that we don't currently support, we will build that connector for them. But we have a very large collection of connections. Take that and then take a no-code pipeline where you can design your own processors, including AI agents, to process content and perform functions. This is exactly what we used ourselves to do knowledge graph creation and to do taxonomy enrichment. Next slide, please. So I'll take an example of classification of content. In this particular example, and this is not client data, this is something we built that's not got client data in it, so we can do that fairly freely. We put into the system recipe books and books about food. We can process those in rich format, so you can see all the pictures and so forth. Then we run classification over them. When we run classification over them, we generate a graph of what that content contains, and in relation and map back to the taxonomies and the ontology. Next slide, please. And that's a little, I mean, you can't see the text there, but that graph, this is a graph of connected in knowledge that's derived from a lot of books and from a taxonomy of recipes. And it builds all of those, all of those interconnections. Next slide, please. I'm going fast. Okay, so now let's look at that other flow of information. So the knowledge graph about content gets built through the process of classification and information extraction, but also those processes can be brought to bear to help build out the taxonomy and the ontology, which is the top two levels, if you like, of that pyramid. So in this particular slide, we started out with a taxonomy that had got about half a dozen herbs and spices. And we told the classification and extraction system to go find more. And that's what it did. So on the far right, it's finding lots of things like ground cloves, chili powder, etc. It's finding things that are similar to the type of thing that we told it to find, and identifying those, and it can then put them back into the right place, in the right category, if you like, back in the in the main taxonomy. Next slide, please. Other things that we can do for enrichment is we can use the power of generative AI to create, to synthesize definitions. So some taxonomies have them, others don't. But if you've got a categorical structure and it's light on definitions or missing definitions, we can use it to synthesize and generate definitions simply by looking at the content that gets classified. Likewise, it can go and find synonyms. So you might have, a category with one or two synonyms and a main label. It can go and look through content and find dozens of other examples and then add them back into the taxonomy. Next slide, please. Fact extraction, which was one of the other methods of extraction, is the identification of a value that goes with an entity, or it is the identification of a connection or a link between two things. And in this particular food example, we said, go read the recipe books and find out what kind of ingredients are used to cook other kinds of ingredients. And the process went away. In this particular example, it's finding broccoli can be cooked with butter. Other thing, it could be cooked with water. It could be cooked with olive oil, etc. But that is finding the connection between two different things and bringing that back into the graph. And when you kind of add all of these capabilities together, you have the ability to do really build knowledge graphs that are both at the content-aware level and at the ontology level, the augmentation of the taxonomies and ontologies. So I went at a bit of breakneck speed there to make sure we can get to Q&A. I'm going to hand back to you, Simone, but please, Daniel and I, because I want to make sure we hit some of the questions that were typed in live as well.
Okay, thank you. Thank you, both of you, for this phrase, this talk, this discussion. Of course, it's extremely interesting to see, again, how we can use those foundational models to then provide us with very precise insights that we could validate, again, as we discussed before. So the two of you have been working together, the teams from Squirrel and the team from Arup. So before tackling some of the questions, I'd like to pose the first one probably of this Q&A, which is, okay, we heard a lot of promising innovation and tech. I'd like you also to touch to some of the challenges and possibly some of the solution that you used to overcome these challenges when you had to classify via LLM. To the both of you, that's an open question for the both of you.
Do you want to take that? We'll take the challenge, and I'll maybe take what we did about it.
Sure. So yeah, one of the main challenges was reducing the noise in the AI generated suggestions. Say many terms initially lacked the relevance or context. We also found that the semantic tagging could struggle with the engineering jargon and the acronyms, obviously. So, say preferred labels, but then the alternative labels that could be very similar. It could just be purely with and without a semicolon, say. But through, I think, say, there were various solutions that I think Dave can can share, and how that noise reduction was achieved, for example.
Okay, so yeah, so we started kind of like with a root data and almost like a blank slate, and yeah, it was generating noise, and then very quickly, so we kind of work with a RUP on a weekly cadence, and it was like, let's run some more tests, let's see what the LLM is coming up with. Let's start getting the LLM to identify the parts of the taxonomy that are relevant. So if you just have information extraction, let's say, over a corpus of documents without any grounding in the domain knowledge, it will generate stuff, but it is kind of noisy. So we figured out fairly early with the RUP that if you contextualize it by saying, don't bite off don't try and swallow the apple, take it in bites. And what we did was take bits of the taxonomy and say, go and do analysis and extraction down this branch, for instance. And once you chunked it down a little bit, the quality of the results came back much better. There is a question in chat about how do we do definitions, and this was something that we worked on very much with you, Daniel. So we use generative AI. This is one of the things you asked us to do, was generate definitions. So we used the system, and the definitions that were being generated were a little bit too much world knowledge, not a RUP world knowledge or a RUP speak. So soon as we identified that was an issue, we tuned the way that the generative AI agent was doing its work, and we said, when you synthesize, go and use the language that a speak, both in taxonomy and in corpus. And once we did that, we started to kind of get those results cleaned up. If I may, one of the other areas I know that was an issue, Daniel, was human in the loop workflow. You needed a way to bring back all this stuff kind of like in a contained way so that you could see it and then control the flow back into the taxonomy. So that was a big area that we worked on. There's a couple of other questions in chat that I'll try and get to. But before I do, Daniel, is there anything you wanted to add to challenges and responses?
Yeah, on your last point, actually, it was very kind of powerful to have, say, the candidate concepts and definitions that could be generated by the AI that could then be displayed through Graphite so that you could kind of interrogate and review, kind of aid the human readable process of reviewing the candidate concepts and definitions in a matching kind of taxonomy structure with those relationships, say, mentioned, which document it's mentioned in, and through that then you could drill down and look at that specific document that has been tagged with those concepts, and that would all would help that human in the loop process to be more focused and more efficient as well in how.
Yeah. Thank you. So Simone, we're exactly on the hour.
Yeah.
There are one or two questions in chat. Do you need to close the session? If anyone's posted a question in chat that we haven't answered, well, I know there are a couple, we will send you by email a response. But I leave it in your hands, Simone, as to whether we shut down on the hour or whether you want to run over a minute or two.
I think we should stop right now, or at least in a few minutes. All the questions that have not been addressed, I read them through. Some of them were actually not during the Q&A, but before, and possibly you already, the two guests, have already touched upon them. But in any case, tomorrow we will reach back all the attendees with the recording of the webinar, with a white paper on these topics that we just discussed, and with a response to all of the questions that we were not able to address right now, given the time constraints. But yeah, so I'll stop the sharing And thank you again for the discussion, for the insights, for the hands-on examples that you gave us. Thanks to all the attendees for being here today. And yeah, please reach out to us if you do have any additional questions, any information, any material that you would like us to provide you with. And see you at the next webinar.
All right. Thank you all. Thank you. Bye-bye.
Okay.